So I'm going to be giving a bit more of an applied talk today, and I want to tell you about some of the work that we're doing at Tennis Australia to bring statistical innovation into tennis. So just a little bit more about me. My current role is as a senior data scientist at the Game Insight Group, or what we call GIG, at Tennis Australia. So this is a research unit that exists within Tennis Australia. Tennis Australia is a governing body for tennis in Australia, and it has a number of roles, including running all of the national academies where tennis athletes who are aspiring to have a career as a professional player are undergoing development. They also are responsible for running the Australian Open, one of the 4 Grand Slams, which are the most prestigious tournaments in professional tennis. So I also have an academic hat. I actually have a joint appointment at Victoria University, which means that I have quite a large research focus, in addition to being able to have opportunities of translating that research into practically meaningful products that can be used in sport, and that's the part that I'll be focusing on today. I also blog on the T if you have interest in tennis. That's all you're going to find there. It's only tennis data science. So, but that's what I love. So you can find some stories about that there. And you can also find me on Twitter at stats on the T. So it might be surprising, but actually I have to credit having the position that I do today to a guy from baseball. And that guy you see here on the left is Billy Beane. So back in the 90s, the Oakland Athletics, a Major League Baseball team, were one of the most cash-strapped teams in the league. Didn't have a lot of resources to recruit the top talent. At that time, Billy Beane was the general manager responsible for talent recruitment and constructing a roster. So he was faced with a real dilemma. Either we go ahead and expect to have another losing season, or we get creative and find a way to make more value out of the money that we have. Fortunately for sports statisticians around the world, he went to a data-driven based solution. And a lot of that had to do with the fact that he was under the training of Sandy Alderson, who was one of the first front office individuals in baseball to take a real interest in sabermetrics, which is the general term for statistical analysis in Major League Baseball. So he was an early adopter, and he had carried on those same principles to Billy Beane. So when he took the role of GM, he continued to see ways that they could start to make better use of the kinds of new performance metrics that were being developed and looked at by mostly hobbyists, like I used to be, who were interested in numbers in sport. Another important key to this story was the hiring of Paul DePodesta, who was a graduate from Harvard, studied econometrics, also loved baseball, but effectively a geek, who Billy Beane was willing to bring in to the scouting room. And at that time, you have to appreciate, scouting was primarily done by a lot of old guys who had been watching baseball all their lives, probably played before they took their scouting role. And they were basing a lot of their judgments on talent, just purely on gut. So really, no sort of science was being used. It was a real risk to bring in someone like Paul DePodesta into that environment, both for Beane and for DePodesta himself. I couldn't imagine what a kind of hostile place that must have been at first. But they had been really doing their research and found that there were a number of measures that were highly predictive of the value of players that they could use to gain an edge because nobody else in the sport was looking at it. They used this, and it became a fundamental part of their decision-making when picking players in the draft or when making decisions about trade. So they were finding the talent that everybody else was undervaluing. Ultimately, this strategy led to 8 consecutive years of a win record over 500. which is a very good thing in baseball. And this book, Moneyball, which you probably have heard of, by Michael Lewis, which eventually also became a blockbuster film starring Brad Pitt. So, altogether, the Moneyball story has had a huge impact on the sport and is really, not only in baseball, but in the sport industry as a whole, shown the potential value that data analysis can have. And so it's for that reason that I have to credit them for the job that I'm able to have now. You can actually see the impact of this work and the Moneyball story by some Google trends. So the Moneyball was really an early 2000 phenomena. And it's interesting to see that if we compare the use of sports statistics, which was the traditional academic term referring to statistical work in sport, and sports analytics, which was industry's rebranding of the same field. Now you can see that early on, sports analytics in the early 2000s is essentially non-existent. Today, it's on equal par with sports statistics, which shows industry's change and embrace of the kind of academic work that previously they were either unaware of or didn't think was worth their time. We can also see the impact in the job market. So here I've taken a photo from this year's MIT Sports Analytics Conference, Sloan, which is one of the premier, it's become one of the premier events for sports analytics work. And the crowd just gives you some idea of the great sense of opportunity that there is now in the field. So it's still the case that the absolute numbers of full-time sports statistics roles are small. But the growth has been massive, and I expect that will continue. So what about tennis? This is my field, and I want to give you a little bit history of what sports analytics development has been like in tennis. To do that, I have to go back to another MIT Sloan conference. This one happened in 2012. What you see here is a picture from a panel that was held that year on tennis analytics. You might expect a panel with that title would all be about the great innovations that were happening in measurement and statistical analysis in tennis. In fact, the panel was a lot of shoulder shrugging and bemoaning the fact that it seemed like the sports statistics revolution was essentially passing tennis by. In fact, the moderator of that panel opened up the discussion by pointing out that tennis had been ranked second to last in its use of statistics, coming just ahead of boxing. So it wasn't a good time back then. Fortunately, there were already leaders and key decision makers in the sport that knew that this was not a fad, the sports statistics revolution. This was not a fad that tennis could turn its nose up at. So tennis is a sport that's wedded to tradition, and it is hard, really, for any new innovations to be adopted. But it was clear that this was an area that they needed to make investment. So one of those individuals is Craig Tiley, who you see here on the left, and he's the current CEO of Tennis Australia. And about around the time of that 2012 conference, they were already putting plans in place to start making a strong investment in statistical innovation. And in a very short amount of time, the kind of support that they put in that area, we are already seeing great results of that. So we go back to that 2012 period. Well, since then, between 2015 and the present, we've had 4 papers on tennis that have appeared at the Sloan Conference, and they're all written by authors from Tennis Australia. So we're already seeing a lot of success. Now, that investment is really about GIG. This is the group that I'm currently the senior data scientist in. The Game Insight group is actually an academic industry partnership. So the industry partner being Tennis Australia and our academic partner being Victoria University. So they've come together and made a 50-50 arrangement to essentially put in a lot of seed funding for R&D development, where there's both academic objectives of producing high-quality research that we share with the research community, as well as commercial development, where we have the opportunity to translate that work into products that can make a real practical impact on the sport. So our main mission at GIG is to really revolutionize the way that we think about performance in tennis. I want to tell you a bit about the kinds of data we're working with that are really the foundation of what we're able to do currently. So we have two main data sources. We have data that both comes from the web, so public domain data, and proprietary data. Our web data is essentially a collection of all sorts of data that we're able to collect from the web. So anything that's out there related to match results or the outcomes of individual matches at a more rich level. We've developed software to scrape the data on a continuous basis and build up a historical database that we can use for doing a number of research studies, but also deriving new metrics that could feed into other parts of our work and our event operations, which I'll talk about in a few slides. So this is actually all done with R scripting, and we store our data in SQL databases. And our main sources currently for these data are coming from FlashScore and the tennis abstract sites. So this would all be data that would be available to anyone who's interested in doing tennis performance analysis. I have also packaged up that data into an R package called Deuce, which is available on GitHub, and it has 20 megabytes of historical tennis data, including data that's at the match level, at the point level, and even the shot level, because there are currently some crowdsourcing projects that are going on to gather shot-by-shot information of tennis matches. So there's quite a good variety for answering a wide range of questions. We also include several derived measures. I think the main one that would be of interest to sports statisticians is our ELO rating system. So that is included in our this Deuce package and would be available for download for anyone on the web. I also mentioned that we do have some proprietary data. That data is tracking data. So this is positional information about the ball locations throughout tennis matches, as well as the player locations. So if you've ever watched a professional tennis match over the past few years, you will have seen the player challenge system. That system is a video review system that allows players to challenge a line call if they think that it was made incorrectly. There's a company, Hawkeye Technologies, that is now part of Sony, that maintains that system. And the way that it works is they have a multi-camera setup on a court. So 8 different cameras are tracking the locations of the ball and players throughout a match. And this is what they use to then reconstruct the ball trajectories if there is a challenge called. Now, it's a little bit upsetting when you first hear this as a statistician that such a company is collecting this kind of data and it's only used for maybe a few calls during a tennis match. So there's a lot of information there that I think until recently has been underutilized. So this tracking data is now collected on most professional matches in tennis. And fortunately, in my role at Tennis Australia, we have access to the tracking data for the Australian Open Series, which would include Sydney and Brisbane international events, as well as the Australian Open. And we had that data going back to about 2012. And currently, in the past few years, and this year as well, we're able to collect that data in real time, which will be important for the work that we're currently doing during the Australian Open. So again, we're using R to analyze these data and not only process them, but to derive new statistics, which I'll describe more in the coming slides. Okay, so I mentioned that we participate in the operations of events. Currently, this actually makes up a very small part of our total effort throughout the year, but it's a critical one because it's the time when the tennis world is looking right on us, and we have the opportunity to make the most impact. So it's a big part of what we do in the sense of much of the time during the year is doing research and preparation for the sort of production phase of the work that will actually take place during an event. Currently, we are providing these services during the Australian Open and Laver Cup, which is a recently introduced exhibitional event partnered between Roger Federer's management and Tennis Australia. But we are looking to expand these functions. So to give you an idea of the kinds of things that we do, I wanted to share some pictures. So what you see here is a picture from the local broadcast in Australia of this year's women's final at the Australian Open. So the final was played between Simona Halep and Caroline Wozniacki. If you look on the court, you'll see a bar graph displayed, and it's giving information about win predictions. At the top, we have a pre-match prediction, which had slightly favored Simona Halep at 57%. Now, at this phase, when this image was taken, we're already into the third set, so both women are now 1-all, and just beginning the fourth game. At that point, the prediction at that stage in the match had swung in Caroline Wozniacki's favor, and the graphic illustrates the amount of that swing. So all of these numbers that you see here are coming from our group and our predictive forecasting method. So we do pre-match predictions during the event, as well as in-match predictions that update with every single point as a match progresses, and allows us to create things like this, which are the things that make me love my job. So this is one example of the kinds of things we're doing now during events. Another one that I'm excited about, and you'll see that our graphics team really loved doing these overlaid court charts. This is the thing that they're into right now. But if you notice, we're reporting here a total work statistic. So this statistic represents a stat of the overall energy exerted by the lower body of players, and we track that throughout the course of the match. So at this stage, they are now playing in the second set, and this was one of the men's semifinal from that year. We're looking at the accumulated work for each player and comparing the percentage difference, so the relative difference between those two. So this is very nice because if you've ever watched tennis recently, you'll notice that there are very few physical stats that are ever reported. It's something that for a sport that is highly physical, particularly these days where there's so much concern about the kind of wear that players are undergoing and increased risk of injury, we have very few numbers to actually understand these processes and the amount of effort that players are exerting. So this is one of the areas that we're really trying to develop. And in this sense, we're really using these measures in our operational setting for fan engagement. So that's what a lot of this is all about. In addition to being able to display new stats and graphics on broadcast, we were also doing a lot on our social media channel and also partnering with the Oz Open channel to get out some interesting stats and sort of a second stream content. So these are some examples of infographics that we created, also highlighting sort of leaders on various stat measures. So again, we were looking at top leaders on our work measure. We also, because of the software that we had built, were able to do some more customized types of analysis as matches progressed. That gave us the ability to go into a bit more detail for an audience that would have maybe a greater interest in a bit more statsy type of displays. So here's an example from the men's final between Roger Federer and Marin Cilic. That was a heat map showing their positional characteristics during rallies. And this went out as that final was taking place. So I think this happened somewhere in the third set. So we were able to be quite responsive to what was happening during a match and engage with fans and the tennis Twitter to try to make an impact from this more statistical perspective. Okay, so I've given you a bit of illustrations of the kind of output that we're generating during events. But how exactly do we get there? So this diagram breaks down the major processes that are involved with our real-time application. So it all starts with the Hawkeye tracking data. So as I described, Hawkeye is the company that's the actual data provider of the positional ball and player information during events. They send us a point XML. That XML file contains information about what has happened on a point that is just played in a particular match. And it includes details about the particular score at that stage in the match, as well as all of the trajectory information for the shots that were played within that match, from which we can derive a number of physical characteristics about the location of those shots, their speeds, and so on. That point XML is first processed by a Windows service, which effectively creates a queuing system. At any one particular time, when we're sort of under the highest data flow, we can have 7 simultaneous matches going on and sending us data at one time. So we have to have a system in place to both check, do an initial validity check to make sure that that XML file is what we're expecting. And then we do some processing to stage it appropriately so that we can have more efficiency in how each of those files are processed. At the core of this whole process is an R package, which we've called the gig engine. So once we validated any individual XML, that's sent to an R application that will then do all of the heavy processing and derivation of all of the stats that we want to make available for broadcast, for our on-site media, or for producing interesting things that we can put on social media. So it all happens here. Once we've done all of the processing, we then have 2 types of output. So one is an XML file, and this is intended for any of the broadcast-based outputs that are going to ensure that they are looking at the results from the most recent point, and also will get the speediest access to that information. So that goes out and is then available to broadcast or other downstream users of that information. We also store what we have just processed into a database that will then allow us to do more extensive historical reporting that could include customized analyses of a match that we haven't anticipated, but we find during the event will be an interesting question to look at. It also allows us to then use those data in reporting that will be done that could aggregate across multiple matches as players progress through the event. So that's a summary of the overall process. Just to give you an idea of exactly, what does the data look like that we're dealing with. So this is an example of a point XML. So it follows a standard XML tagging structure. You can see information about who was serving and receiving in this particular point and match, the score, And then below will be a set of information that will include the trajectories for the shots, and then following that, information about the position characteristics of the players throughout that point. So that's what we're dealing with. What about what we deliver? What exactly are we providing in our processed file? So it's mostly a lot of performance metrics, which I tried to diagram the key features here. So we have, at the very top, our win prediction. So within that XML file would be the updated information about our expectations of the likely match winner, which will include information about the current score and how each player has been serving over the course of the match, as well as our pre-match expectations. So all of that's taken into consideration in our in-match forecasting method and is included in our XML output. Everything else are measures that fall within four key areas of performance in tennis. There's the mental, the physical, the tactical, and the technical. So the mental is really about the inner game and how players' temperament is affecting their performance. And we have a number of stats that fall within that. Our main ones include clutch averages, so clutch ability being effectively how players are handling game pressure. We have a suite of clutch stats. We also have measures of leverage, which is the actual measure of how much pressure is present at any particular point. Our tactical is really focusing more on the decision-making aspect of performance, and we have a number of measures related to the time pressures that players are putting on their opponent, the versatility in their shot selection and movement. The technical is all about the physical characteristics of the shot, so the actual quality of the execution, and that goes down to things like the speed, the location. That would all fall under our technical measures. And then the physical, so that would include our work stat. We look at changes of direction, measures of agility. So all of this information would be included within our XML file for every single point that's happening in the matches that we're processing. Okay, so with some trepidation, I'm going to try to show a demo, since a lot of this is about actual processes. So to give you an idea of how this works, I've here put one example of a XML, and this is exactly the kind of file that we might see come in from our Hawkeye data provider. So now I can scroll down and give you a better idea of exactly what all that data is in here. So you can see our trajectories for the shot locations are described by three-dimensional polynomials, each one being described by a third-order polynomial. So they correspond to the x, y, and z dimensions. So there's a number of those corresponding to all of the shots that took place in that point. And then at the very end, we have a 25 hertz sampling of the player positions, which give us a two-dimensional coordinate that corresponds to the center of a player's stride. So this is being gathered at a 25 hertz sampling rate throughout that point. Okay. Now, it was interesting to me to be in the audience today and see how much focus there was on automation. That's really critical to all of what we do, and to be able to make an R-based real-time application actually work. So we already saw some examples from Andrew about the use of Rseript. So that's a key part of our strategy for automation. It's a built-in executable with base R. So it's available to all of you to start using. And it allows for command line execution of our scripts. So in the example that you see here, I have a run file which encapsulates all of the gig engine main workhorse function for processing a source file. And then I have a number of arguments that will allow me to control where that data is going to be stored. It will allow me to input any variety of files that are coming in, and also to assign other variables that may be relevant for our functional processes of the engine. So let me run this to give you an idea. So you'll see the Rseript will show the processing of that file, and we provide some output for ourselves to monitor success and failures, so effectively a status update for an individual file. Now, if we look back into the desktop where my source file was located, you'll see a number of files have been created. So in this instance, I've directed all of the output to just go to the desktop so that we can all view it. So this XML file is actually an example of the output that we provide. So this is the resulting processed file. And if I just scroll down, you'll notice that there's quite a lot of content there. Essentially, the different nodes that you see in this XML correspond to those major metric areas that I had pointed out in the previous slide. So we have our clutch measures, and then as we go on, we have shot-specific stats corresponding to each player and shot that took place within that particular point. And then at the very bottom, we have some of our physical movement measures. So this is a thing that we forward on to other departments, such as our digital team or our host broadcast team, and they're able to then have processes in place to pull out a particular value of interest, whether it's a win probability or a total work stat. And that's the step just before being able to actually broadcast that on a match. The other files you see are actually our storage files, and this would be the basis for building up, accumulating this information from a single process file over time and being able to transfer that to a database for long-term use. So, a big part of what we do is, in terms of our design, is modularity. This is a really important thing to being able to have readable code and for doing debugging. So a lot of the work that we do is quite complex. We build up a lot of functions over time, and I can actually give you a sense of that by bringing up our engine. So here's an index of the actual functions that make up our real-time application, our engine. So scrolling down, you can see that a number of these are very small things that relate to different pieces of building up stats related to shot characteristics, movement characteristics. I can point out one of these, for example, the height off the net. So this is a function that is going to calculate for a particular shot the distance that separates that shot from the net as it passes over the net. Okay, so this is a very small part of just one characteristic of a shot, and we've written a separate function for that thing. So this is exactly the modularity that I'm referring to, that we try to break things down into very small parts. And we find that this really helps with the development process because if an error occurs, it's much easier to identify where that's happening. Okay, so to give you an idea of the actual workhorse function and the step that actually creates this XML output, I wanted to give you an idea by having a look at one of our key functions, and that's the make XML, which is really the final step before we produce our output. So if I look down here, this goes to a complete XML, and so all of this content is really about preparing the data to then go on to being processed. And if we bring up that complete XML file, you can see a bit more of our modularity actually at work. Okay, so that wrapper contains a key function, complete XML. Within that, you can see a number of functions that have a close correspondence to the source output nodes in our output XML. So we have clutch measures, point summaries, stats happening on serve, the time between serve, and so on. And eventually, all those steps give us a collection of character values that are going to form the final XML. And this is really the final step that puts that all into a structure that has a valid XML format. So my goal here in just walking you through this is to give an impression of the importance that the modularity has in our design principles. So I mentioned before how automation is a key part of our engine and our processing. How many of you have worked with Rseript? Do you have some familiarity? Excellent. So it's ideal, especially if you're on a Linux Unix system, and it's important to keep in mind that you can also provide arguments. So I don't think we saw an example of that previously today, but that's a critical one for us because we're dealing with, variable data. Sometimes we need to be able to store that data in different locations for greater efficiency. So that's a critical piece of being able to work with this. The great thing is that it's readily available and now a fundamental part of the base R. I wanted to give you an example of what a particular script would look like. So that's actually supplied to the Rseript for producing our output XML. And this is essentially it. So if you aren't familiar with passing arguments to an Rseript executable, you would simply do that through the command args function. So this will collect all of the arguments that are provided after your specified script as a list, and then that makes it available to you for passing on to any functions that are included in that script. So it gives quite a lot of flexibility. So this is the basic syntax that we previously saw an example of. So I have stored all of the code that you see above as a script called run-r, and it's effectively loading the gig engine functions, collecting the arguments, and then our only function that needs to then be processed to produce the output of interest is this make XML file. Our arguments allow us to collect variety of new data as it's coming in, and to be able to have flexibility in how that is stored, both where we're going to pass on the individual XML file as well as store those longer-term historical data sets. Okay, so we saw the automation in actual work. But where does that XML actually go? How does anybody have access to it? You could imagine a number of ways that you would handle that step, sharing that information with someone downstream. The way that we've done it is by setting up a simple web service, which has the nicety that anybody that has an internet connection and appropriate authentication information would be able to access that content. It's a fairly bare bones version at this point. We're working on expanding it to allow more flexibility in actually requesting particular elements within files, but currently it's been designed to just return the most recent processed point for an individual match. And I can give you an example of how that works. Since it's on the internet, we can actually see it at work here. So I'm putting in a match code, so every match, professional tennis match that we process will have a specific unique identifying code. I provide that, and then the result is going to be the latest point that was processed for that match. This match actually corresponds to the men's final at this year's Australian Open. And you can see that it has the structure that we saw previously. That includes our main metrics and win probability information. So this is what our broadcasting team, downstream users would be dealing with for producing any subsequent content based off of that output. In doing this work, it's still fairly new to us, but we have come across a number of useful lessons that I wanted to share with those of you who may be working on similar real-time applications. So I already mentioned modularity, and it's something that we do think can carry over and isn't necessary for a real-time application. I think anybody that's doing any extensive development in R could benefit from modular design. When we're at the point where we're looking at optimization, that's a key step, particularly when the speed of your processing is critical. And I find that the line-prof package for profiling was an essential tool in looking at what were the major bottlenecks. So if that's new to you, I would definitely suggest having a look at that package. It's another Hadley Wickham work, so, and he includes a discussion of it in his advanced R text. We've already seen plenty of tidyverse examples here, so I probably don't need to say too much about this, but it's something that we follow in our package design as well. And there are multiple reasons for that, including greater performance efficiency, as well as readability of code, which can be important, particularly when you're working in a collaborative team and are sharing responsibilities of your package development with others. On optimization, so that is a critical part, as I mentioned, to what we do. And there are a few things that we've utilized so far that I think would be helpful to share with you as well. So when we did our profiling, it turns out many of the bottlenecks in our original design had to do with handling of data frames. So any kind of manipulation, R binds, C binds, these guys, for some reason, weren't being handled very efficiently. Fortunately, the R community was aware of this long before we were, and there's a number of packages actually out there that can help with faster handling. I'm sure this isn't the only one, but we're currently making use of data table functions for a lot of those basic manipulations of data frames. And that's actually helped us gain quite a lot in our performance. So another thing, of course, is parallelizing your work. Now, some of this happens naturally already with functions, some of our standard packages and functions in R. But if you do find that you need to go even beyond that, There are things like the do parallel. We actually saw an example already from Sean's talk earlier today of how this could be used with web scraping. For each is also another popular package for spreading across your processing. And of course, these examples are thinking of introducing parallelization in the absence of additional hardware. So of course, that could also be another way that you could go about by using a cluster of CPUs, for example. For us, we found that we haven't needed to go to that stage, which is nice, and it was a bit of less kind of effort. We can focus just on local solutions, but that would be another place for those who need to even gain further speed in their application. And then finally, I wanted to mention the use of other languages. So we know that compiled languages like C++ are inherently more efficient at many processes compared to interpretive languages like R. And at times, it can be important to utilize that. And there are utilities for doing that quite easily these days. So RCPP is probably the best example of being able to have an interface directly with another language and be able to benefit from the strengths of those third-party languages, let's say. So that would be another key thing that in our own experience we find has been important when we're at that optimization phase. Okay, so in addition to our real-time point-by-point analysis, during our events we are actually also creating more customized reports that have a bit more detailed, readable information about performance characteristics that have happened in a match. The idea for these is really for media engagement. So with these reports, because we have the ability to include text, graphics that wouldn't be available to us in our XML output, we're able to do more on the actual side of storytelling, which is a critical part of our group making an impact and showing the benefit that our tennis stats can have for adding to the understanding of what's happening during an event and just the general experience of these competitive events. To give you an idea, I'll just go to the full report, since you could only see part of it there. So this is an example of one of the what we called a match preview. So prior to the actual men's final, when we knew that Marin Cilic was going to be facing Roger Federer, we were able to create a report that had a number of summary stats for each player, and it corresponded to what they had done so far in the Australian Open itself. So there are 4 players that reached the final of a Grand Slam. They will have played 6 matches to get to the final. So this would include summaries of each of those key performance areas based on those previous 6 matches. And so the idea is that it's going to provide kind of the most recent idea about each of those players' form and allow you to do a direct head-to-head comparison because we're providing that information about each player in the same row. We also include a comparison against the top 10 average, and that's a historical average for how top 10 players have performed at the Australian Open over the past 5 years. The actual stats themselves include some of our mentality stats, technical stats about shot, positional information, which is going to be more of a tactical type of characteristic. And then at the end, you see a number of our measures around the physical performance of each player. So this is a very condensed version of all of the kinds of measures that we're producing. And we found that that's actually an important part of producing a more impactful report. So the idea is that this is something we're going to send out to the on-site journalists at the Australian Open who are creating the stories, writing the narratives of what's happening at the event. They aren't data scientists, and they're not going to want to scroll through spreadsheets and spreadsheets, even as interesting as we think they are. So we found it's really actually critical to be concise and pick out the best of the best when designing these reports. Okay, so how exactly do we do this? We actually create all of these reports in R Markdown, and again, we have an automated approach for generating them. So once we know that a particular match is going to happen or a particular match has already happened, we're able to run that script, modify a few parameters, and generate a new report that's ready to print and send to the media room. There are three main R Markdown templates that we had in place for the three types of reports that we were producing during the event. So one was a set of player profiles, which were reports that were done the first day of the event before any matches had played, that gave a historical summary of player performance at the Australian Open. We had our previews, which you've seen an example of, and then we also had post-match reviews. And they all follow a fairly similar structure. To give you an idea, this is the metadata for one of our templates, one of our template match reports. Now, if you haven't done automation in R Markdown previously, key thing is to be aware of is that you can actually run a Markdown report from a command within R itself. So using R Markdown and render, you can produce an R Markdown report. And when you combine that with our script, you can actually pass arguments on through our script into that Markdown file. And that all happens through this params feature that I'm very thankful R Markdown has. So essentially, the params is what allows you to have variable inputs. You can almost think of it as like if you make an analogy of your R Markdown document to a function, then the params are essentially like the arguments of that function. And their actual values that they take becomes the values for those arguments. So this gives us a great ability to be very responsive as matches are completing, because the time is so important in that kind of setting for being able to make more of an impact. If an hour goes, 1 hour can make a big difference between whether or not a journalist includes any of your data or not. So this has been of huge value. To give you an idea of an actual match report, so here's an example of the template for a match report. So you can see we have some information that will be displayed as usual, title, date. You can actually embed functions within these elements of the R Markdown metadata. Something, when I discovered, I was quite excited to have, because again, days change over the course of an event, and we need to be able to include that without having to make manual changes to our report template. So for this particular report, we have 2 players. We also have a match ID and then information about where the data that will populate where information for that match will be available. Those all constitute the particular parameters for this report. From that point on, there's a combination of some HTML for producing some of the aesthetics around the report. An important part of that is a style sheet. So we found it very useful to control all of the aesthetics through a style sheet. It's an excellent way of separating the aesthetics from your content. So you'd really prefer to have your Markdown file purely content-based, and then using the style sheet is an effective way of doing that. And then below, we have a fairly basic kind of Markdown file. we're grabbing a lot of the data, and then we're creating a table. So most of the data that we provide is in a tabular format. And in the match reports, we break these down into different sections for easier use. So this is an example of the script that we use to actually process. So here you see the R markdown and render, and that then links to the particular match report markdown file that I just showed you. But otherwise, it looks exactly the same as the previous run script that you saw. So for real-time R markdown, I already mentioned thinking of your document as a function. If you haven't appreciated that R markdown has that ability, it's a really amazing thing to discover, and especially if you do have instances where automating those reports would be useful. One of the things with the design of that actual template is making sure that it's generalizable. So, a lot of times with one particular match, you may find that having the axes with particular limits works well, but then it completely breaks another one. So it's important to think about the generalizability of the design as well when you're going to be processing over a lot of different types of instances. And as I mentioned, the style sheet's an effective way of separating style from content. Robustness with these applications, particularly when other parts of your organization depend on you to deliver, it's really critical. And testing is the main way to get a more robust product. So test, of course test, but how do you anticipate what's possibly going to go wrong? Sometimes you can anticipate possible errors. Other times it's hard to know, and you don't want to be in a situation where it happens as the event is going on. And if you're unsure how to find it out, I think the best way to do is get a representative set of possible inputs that you could see and actually simulate that event to the best you can. So we do massive amounts of simulation prior to any event. It doesn't mean you're going to still identify everything. You still have to be prepared that something new could come up, and how will you respond to it then? But at least you'll know you've made your best effort. So it's interesting, when I was preparing this, I thought back to a talk I was fortunate enough to be a part of as an audience member, and that was when John Chambers spoke at the 2014 UseR. And the theme of his talk was all about the future of R. And this quote here points out, his reflections thinking back to the birth of S, the predecessor of the R language. And, at that time, I think they were largely thinking of we need a better tool for doing interactive manipulation of data objects. And now you can see that there's so much happening in our development that's really focused about production. We've heard so much about automation today, like having processes in place that can basically run on their own. So we're, very much seeing more and more examples of sort of non-interactive type of use of R. And, Chambers pointed out that how will the language keep up? Being open source, it's entirely reliant on its volunteer community. And a lot of the things that we are trying to do now, require interfacing with other languages, other types of tools. How will it get there? I'm very optimistic. I think we already see a lot of examples through developments like Shiny, OpenCPU that are allowing people to build web applications more effectively using R as in the back end. So I think we're just seeing the activism of the community, the creativity, its dedication to making cool stuff that still appears to be working, and I'm just very thankful to developers in the community who make my work possible, and I'm very proud to be a member of that community as well. So I hope you've found some of this interesting. I've had some resources for some of the main tools that I've brought up in this talk, as well as material from the slide and the workshop from Friday. And then my contact info. Hope we get a chance to talk later, but if you'd like to contact me after the event as well, I hope you will. So thank you.
There's just one of them. Okay, well, I'll have to shuffle back. Okay, any questions for Stephanie after that really nice talk? Okay, I've got one. I'm going to start here because it's closer.
So, thank you for that talk. That was fantastic. I'm not much of a sports person, but I really enjoyed that a lot. I suppose, for me, I found my mind wandering very quickly to the fact that you've effectively made what would be the self-driving car version of an athlete by being able to do all this analysis in real time. I thought that was interesting. But also, if this is able to be done in real time, what then becomes the ethics of how this would ultimately influence the sport by people being able to track what their opponents are doing and knowing how to effectively respond to that? I just sort of...
So all of the information that we provide to our departments for publication, whether it's on the broadcast or to media, it's always on an equal basis. So if we are going to do a player report, we're going to make sure we're going to do the top 30 players, and they're all going to get the same analysis. If we do a match review, we're presenting the same stats for each player. So I think in that sense, it's really, it doesn't introduce any kind of inequality in how we're treating them. And it's really directed more for descriptive informational purposes for fans that are viewing the sport, to add to commentators to give them a better idea of what's actually been happening in performance in the event. So we actually see it as a very as a benefit to really all people participating, both from the commentary side, to the players themselves. So in that sense, for anything that's public, we make a real effort to make sure that it's equal treatment. But it is an issue that come up. We had a case in the event where we had a specific request from a top player to do an analysis of their service patterns as well as their upcoming opponent. So that was an instance where that was definitely giving a competitive advantage because only that player was going to get that report. And, I raised a red flag. Ultimately, I'm a small peg in the wheel as the data scientist. So you try. Those things do come up it's effectively a business, right? And unfortunately, those issues will come up, and you just try to defend your principles when they do. So the way that we dealt with that was to say, well, we would make that same report available to their opponent.
So you've been covered. Yeah. Okay. So there's another question. Yeah.
Thanks for the nice talk. I was wondering, from more of a finance or what might relate to the first answer that you gave. Do you have any kind of request from betting companies? I think from some of the stuff you mentioned that you might have some financial implication. Is it also even for fraud and so on? So first of all, is there a request from betting companies or anyone doing sport betting, to get some idea on some of your stats? And the second thing, just a minor one, how does your prediction comes? How well the prediction machine works? Do you get as close to your pre-match prediction at the end of the match? And is it just a kind of a development process, or do you have put a well-trained predictive machine? Thank you.
So the first question about betting companies, are they interested in what we're doing? They haven't approached us. I've had conversations with some professionals in betting. Our particular approach does not rely on betting looked at odds because they were anti-automatic track point to point, and that would be another source for making a prediction. We made a conscious effort to be independent because we want to make sure that our method is totally transparent and reproducible. Our method has published scientific papers describing how we do it, and that's a value for us being an academically based group. Interestingly, although we haven't had vetting studies approach us, we have had our integrity unit that monitors corruption in the sport around betting approach us because they see it as a potentially valuable tool for monitoring suspicious behavior. So they already track unusual betting odds, but if they have an independent system that can also say that maybe the performance is unusual, that could better build a case for likely corruption. The second question regarding, I guess it's essentially about the performance of the pre-match predictions.
How will the pre-match prediction match to after-match prediction or the final outcome? Is this get us close to, or how big is the difference between?
It varies. I mean, any individual event, it's 127 matches on any single straw, so events and women's. So it can vary event to event, but from our research, we're about 70% accuracy. And we have ideas about how we can get better.
Is there one last quick question?
Okay. It's a very quick question. On the juice package, how often does that get updated?
It depends on the updating of the sources. So right now it's up to date through February this year in terms of the match results. We try to keep it as up to date as all of the sources are up to date. But that can vary a bit by the various.
But it's all ranking terms.
It's
It's ranking terms.
No, there's much more in there. I mean, there are the results of matches going back to 1968, and for the men's and women's scores. There's point by point data that would say from the very individual point. There's shot level data that actually describes the type of shot happening, and each of those, obviously, the written data is available for a more recent time period. It doesn't go back as far. But there's a variety of sources depending on the question.
Okay, I think it's time for afternoon tea, but please join me in thanking Stephanie and all the previous speakers.